Most paint manufacturers fail not because they lack chemical, but because they don't understand the system. They copy formula, they rush production, and they wonder why their crack filler fail. Today, I will slowly show you how professional actually build premium acrylic crack filler. Not guessing, not WhatsApp formula, but factory logic. I run a paint production business and I train manufacturers, beginners and professional to stop guessing and start producing correctly. Now, today you're going to learn the factory tested, contractors approval and export ready logic. Now, today's tutorial is going to be divided into three sections, but I'm going to take time to explain properly for you because I want you to get the right order. Now, we start by what's a premium crack filler? What is it? Because I know a lot of you, you just hear the word crack filler and you'll be wondering. Most persons call it acrylic crack filler. So now, crack filler is not a paint. It is a structure repair coating. It must move with the wall. Also, it must not shrink on the wall. It must not be powdered after application like dustiness. Every chemical in this system has a job. Elastic is engineered, waterproofing is engineered, sandability is engineered. Nothing here is accidentally. Alright, so let's talk about the chemicals. Now, why acrylic binder needs to be 50 to 55 solid percent, why calcium carbonate needs to be mesh size, why it matters, why talc is not a filler replacement, and why fiber stop crack memory. So we're going to look into this one after the other. I'll briefly explain it to you for proper understanding. Alright, so number one, why acrylic binder must be 50 to 55 solid percent. I know a lot of you used to hear these, some of us that are professional paint manufacturers, you always hear 50 to 5% solid or 60% solid and you be confused. So today I'm going to break it down for you to understand properly. So first, what is solid? What does it really mean? So when you say 50 to 55% solid, we mean 50 to 55% of the binder remains on the wall after drying. It's as simple as that. You understand? So when you hear 45 to 50% is watery binder, that means it will evaporate. So solid is the actual flame that holds everything together. So when you hear the word 50 to 55, when you hear 60%, you probably know that the content of that paint it's going to be or remain on the wall after drying, which leads to the waterproofing as well. So now, what happens below 45 to 48 solid percent? Now, if the binder solid are too low, it has a weak flame, poor cracking, breathing, powdering after sanding, poor water resistance, and crack repeller after drying. So you see the reason why most of the times you produce acrylic crack filler or even a screedy wall putty paint and you'll be wondering how come it has this powdery substances and and it's cracking. So it happens when you add the percentage of your binder. And I know most people want to cut costs because of based on the market quality. Like I said, this is a primer acrylic crack filler. You understand? So if you want the cutting costs on, then you should also be able to manage other chemicals to have a durable product. But that's not what we are talking about today. So now, why the weak flame, the poor cracking, and all of that? Is because there is not enough polymer left to one, lock the fillers together, struct with wall movement. You understand? That's to say the stretchness during the application process and resist alkaline, and moisture on the wall. So low solid equals to fake volume and not enough strength. Now, what happens above 50 to 60% solid? So if the solid are too high, one, the product becomes too stiff. Two, poor knife grit, that is the application process. And the third is difficult application and high cost without proportional benefit. You see, most of the times you see a lot of people they go mistake. That is why I told you paint manufacturing has a system and it's an order. So if you want to reduce cost or you want to reduce your chemicals, you should know how to reduce it properly. Now, if you want to increase your acrylic, you should be able to know if this increment of this binder is what this product need. Because let me be honest with you, most of the times when you increase some certain chemical, it kills the chemistry functionality of that paint. And you can see what I just explained to you. What happens when the binder is above 55 to 60% solid. That is to say, there is a specific binder solid rate that is meant to be used for this premium acrylic crack filler. So you need to understand it happens to every other types of paint as well. Now, why is 50 to 55% is the sweet spot? I'll tell you. At 50 to 55% solid, acrylic binder, one, forms a strong elastic film, penetrates the plaster and cemental properly, holds fillers tight without brittle, balance flexibility plus workability, sands without turning dusty. This is why professional crack filler and repair compounds globally sit in the range. So binder solid control strength, elastic and durability, not thickness. Hope as in you're getting what I'm explaining to you. So now number two, why calcium carbonate merge size matters. See, you need to understand this properly. Your calcium carbonate merge size matters for every type of water-based paint you want to produce. Even most solvent-based paint that uses fillers, you understand? So the mesh size, particle size should be corrosive mesh, which is 200 to 400 roughly and griftle. Now, medium merge to be 600 to 800, okay for a low grade filler. Now, mesh size 800 to 1200 is premium smooth fillers. So that is to say, the type of the calcium carbonate used for your premium acrylic crack fillers determines the grade of the fillers and the total outcome. Now, what corrosive calcium carbonate cause? If you use a corrosive calcium carbonate, that is the big size, not smooth, rough knife feel during the application process, poor surface smoothness, low coverage, visible green after sanding. I know a lot of painters experience this process. Weak picking between particles. You understand? So this leads to one, highly porosity, two, poor binder efficiency, three, high water absorption. Now, what fine corrosive calcium carbonate does, which is the 800 to 1000 merge, one, peaks tightly, low volt space, need less binder to lock the particles. Do you hear? It need less binder to lock the particles. For most of you that want to produce a premium durable paint, this is also the secret. When you work with the right calcium carbonate merge, it helps you reduce your binder in a right flame. You understand? So now the thought, it gives smooth, creamy application. And the fourth is sands cleaning without tearing. At times when you're sanding, you start seeing breakage line. You understand? So this mesh size, which is the 800 to 1200, gives a sandy cleaning without tearing surfaces. Now it improves coverage and finishes. You understand? So think of it like the sand. You understand? Stone don't pick well, or rather stones don't pack well. Fine sands lock tightly. Do you get, or should I explain it again? Think of it like the sand. Stones don't pack well. You understand? Stones don't pack well, but fine sands locks tightly. So when you have a stone and you're packing it, of course, you can pack it well. But when you have a fine sand, it locks tightly, smoothly. So this is a simple example of how these different types of calcium carbonate merge works in your surface application. The mesh size controls smoothness, strength, and binder efficiency, which I've just explained now. So now let's look over to why Talak is not a filler replacement. I have a reason of taking my time to explain all this process for you, because this is an example of when you hear me say follow the system and follow the order. So now this is one of the biggest beginners mistake. Even professionals, they know about talak, but they don't know that it cannot replace fillers, which are your calcium carbonate. You understand? So what talak actually does is, one, plate like flat particles, hydrophobic, that it repels water. It's soft and slippery. It is not a body builder like calcium carbonate. Let's also look at what talc is used for in crack fillers. For some persons that will be wondering, why did I need to add this talc powder to fillers? One, it controls shrinkage. Two, improves the knife guido. It reduces surface tension. It helps prevent cracking during drying, and it improves workability during the application process. So what happens if talc is replaced with calcium carbonate? Remember, we are talking about why talc is not a replacement to fillers and calcium carbonate is a filler. So if you use talc instead of calcium carbonate, one, weak structure, poor compressive strength, poor adhesion to wall, low durability, and high failure rate. Why? Because talc does not pick tightly. Also, it does not provide bulk strength. It does not reinforce the flame. You see, calcium carbonate builds body. Talc controls behavior. They are partners, not substitutes. You understand? So now we'll move over to the fourth chemical, why fiber stops crack memory. I know a lot of you don't are not familiar with this particular chemical, but some of us that are into fiberglass and all that, of course, you know about this chemical. So let me explain to you why it's important you add this particular chemical into your acrylic crack filler. One, this is an advantage, but it's critical, because what crack memory means is that you will feel a crack. If it drives smooth, then the crack reappears in the same line. This means because the fillers shrinks, remove differently than the wall, lacks internal reinforcement. So now, what fiber actually do is that this fiber glass creates a micro reinforcement network. It spreads stress across the filler's body. It absorbs movement energy and it stops stress from concentrating at one line. Think of this concentrated like this. Cement alone cracks. Cement plus steel doesn't, and it's same logic. Now, what happens without fiber? Without fiber, stress concentrates at the crack line, acrylic stretches alone, flame weakens over time, and cracks return. What happens with fiberglass? Now, with correct fiber loading, the crack movement is distributed, fillers stretches without tearing, no crack reappearance, and long-term durability. That's to say, acrylic gives flexibility, fibers give structure, memory, control. So that's to say acrylic binder 50 to 55% is for strength and elasticity, and the calcium carbonate 800 to 1000 merge is for smoothness and picking, and the talc is for shrinkage and workability, and the fiber is for crack memory prevention. You understand? So you don't choose chemical to fill a bucket. You choose them to control behavior. This is the difference between guessing and manufacturing. So now, in a professional factory system, let's look at why other destroys or saves product. Now, same chemical, different order, complete different product. This is where beginners fail. Now, so let's move over to the step-by-step production process for producing your own premium acrylic crack filler, because you're not only just learning the logic, but also you'll be able to produce your own acrylic crack filler wherever you are in the world. So now we'll start by step one, which is the water phase. So in this process, you're going to add 4.5 liters of clean water, and please take note, it's 20 liters production process. So now after adding your water, you put on low speed. You understand? Water helps the chemical to mix properly because it's a water-based paint, and water becomes the continuous phase of the system. It allows dispenser to dissolve very well, fillers to wet properly, thickness to hydrate later. This is for the chemical phase. So now let's talk about the physical phase. That is to say, the application process on the wall. So now water creates a smooth liquid base. It reduces friction before solid enter, and it prevents dry powder from clumping. And if you skip or rush, one, powder from lumps, poor dispension later. And that is why a lot of people make mistake because they are not following the order. Either they are adding lesser water or they are adding more water. So this is the system, this is the order I keep talking about. So like I said, if you skip water or you rush water, one, you have a powdery from lumps. Two, you have poor dispersion later. Three, the thickness has this fishy eyes during the application process. And of course, you have inconsistent viscosity. See, water is not just a carrier, it is the foundation of the entire system. If the water phase is wrong, everything after it will fail. You're finishing, you're able to see what you produce. You understand? So now move over to step two, which is the dispenser addition. So you pour in your carbon PT and mix for about 2 to 3 minutes. Now, what happens chemically when you add calcium carbonate? It dispenses the coat, fillers, and pigment particles. It creates electrostatic repulsion. Okay, let me reduce it. Okay, it creates like it breaks down all the fillers and makes the outer finish become elastic, kind of, which a lot of people are not familiar with. Also, it prevents particles from sticking together, which so many people are not aware of. You understand? So now what happens physically? Because we just finished, they talked about what happened chemically. You understand? So the solid remain separated, low viscosity during filler addition, and better packing later. And now, if you skip the Cargon PT, what happens? The filler agglomeration, you understand, which is going to make it, they 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 won't blend properly. Then high viscosity earlier and poor coverage. A lot of people will be wondering, oh, and of course, sitting after storage. You know, most of you encounter this process after production. It has happened to me in the early stage when I started paint manufacturing. I produced over 604 liters of emulsion paint, and at the end of like 3 weeks, a month, I had my customers, because I deliver to the paint hard store. They were calling me back to say that some painters said that the paint was strong and it seated below the bucket. So if you don't want to encounter the kind of embarrassment, because it's an embarrassment, you understand, you have to incorporate Cargon PT. You understand? And not only Cargon PT, you have to also add Juniper. But we'll get to that, you understand? So the Cargon PT helps during storage time. And it's not only during storage time, it also gives the paint elastic frame, which so many people are not aware of. And when you're adding your Cargon PT matters in the beginning of the water and after the water. You can also add it after, at the later stage of your production process. You understand? Because it serves as a plasticizer also. But some people get it wrong, because when you add your Cargon PT at the last stage, it doesn't dissolve properly. You understand? It gives until you, let's say, you have to make sure that paint will sit. Sitting means that paint has to stay down for like 2 days, so all the chemicals can blend properly. You understand? I know most of you might not be used to all this process that I'm talking about, but most of you that are already paint manufacturers, I know you might have encountered this process. You understand? So for some of us that are going to be selling our product in the market, or are going to be putting our paint in the store, we are not just producing and we are applying direct to the wall. Then you need to know how to put the right measurement for your Cargon PT, not even for storage. You see, this Cargon PT helps a lot of wall surfaces. You understand? So these steps control how particles behave without dispenser. Fillers fight each other instead of working together. So now we move over to step 3, which is the pigment seeding. So every small, okay, yeah, you can just add very, very small titanium dioxide. I wanted to explain the reason of the addition, you understand, which I'm also going to talk about, you understand. So what happens chemically when you add very little titanium dioxide? Titanium dioxide acts as a light scattered nucleus pigment. It improves brightness perception. It helps body appearance, not opacity. Now, what happens physically when you add titanium dioxide? See, titanium dioxide gives visual density. It makes filler look richer and premium, which a lot of you are not aware. I know people want to produce the acrylic crack filler. They don't even put titanium at all. So now I'm telling you the reason why you need to add very little titanium dioxide. And the next is it improves contractor perception. Now, if you skip titanium dioxide, what is going to happen? You have dull appearances, cheap looking fillers, poor visual coverage. This is not about color, it's about visual body. A premium product must look premium before it even touches the wall. So let's move over to step 4, the primary filler addition. So now you add your calcium carbonate, of course, 800 to 1000 mg. You add slowly. Now, what happens chemically when you add your calcium carbonate? Calcium carbonate becomes a structure skeleton. It builds with the acrylic later and it controls density and coverage. Now, what happens physically? as you're producing. Now, it builds body, it controls smoothness, and it determines the sanding feeling. Also, if you dump calcium too fast, you get one lumps, air entrapment. Please listen. Hope you're learning something. Whenever you dump calcium carbonate in your water-based paint, you have lumps, you have air entrapment, and you have poor dispersion. So that is why you need to add calcium slowly. Be it you're using a turning stick, or you're using a stirrer, or you're using a hand mixing machine, whatever. You understand? Because calcium carbonate builds the body. If it steps in wrongfully, nothing can be fixed later. Even if it's bulky and you use your hand to separate it, you put your hand into the drum or use a stick to do, it has already affected that production and is going to reflect in the final finishes. So now let's move over to step 5, the secondary filler, which is the addition of the tack. So what happened chemically when the tack is added? One, tack plates are learned within the matrix. It reduces shrinkage stress. It improves flow behavior. What happens physically while you're producing or while you're doing application? It has a smooth knife griddle that when you're applying, and of course it reduces cracking during drying, and you have, of course, you're going to have a better workability. Now if you use tack as calcium replacement, you're going to have one, weak fillers, two, low strength, three, poor durability, because you are not meant to replace this particular filler as calcium carbonate. Talc does not build strength. Please take note. It controls behavior. This is where beginners make expensive mistake by following random formula. So now we'll move over to step 6, the reinforcement, which is the fiber glass. So now fiberglass powder should be about 600 to 800 RPM. You understand? So what happens chemically when it is added? It creates micro reinforcement network, it distributes stress and controls crack memory. So now what happens physically? It stops reappearing crack and improves tension strength. You see, most of these chemicals does one or two, three or to five functions in a production process when added. It also improves long-term durability. So now what happens if skipped? Do you understand? Crack returns, contractor complaints, and product rejection. You understand? This fiber is not filler, please. It is the anti-crack backbone. Without it, crack returns, filler split, and the contractors complain. So we'll move over to step 7, which is your modifier, which your Jeniper, you understand? So what happens when you add your Jeniper? It controls flow under shear, it stabilizes the particle suspension, and remember that your Jeniper is also a wetting agent. So what happens physically when it's being added? Smooth spreading, no sagging, no sitting or settling of the paint. So if skip, you have the poor knife feel, slumpy, and storage instability. This step controls how the product behave when applied and when resting. That is the function of Jeniper. It works for your product when it is being applied and when it's being sitting. It stretches. So the way you incorporate your Jeniper into your production matters a lot. You see a lot of people, they over add Juniper and it makes the paint excessively slippery. So there are some paints that you don't even need to add more Juniper. In fact, you need to add just a drop of Juniper because that drop helps that paint when it is sitting. And when the paint is being applied, that little Juniper acts its own functions to help the product behave. You understand? So let's move over to step 8, which is the deformer. So what happens when you add your deformer? Of course, you all know deformer breaks surface tension of air bubbles. Do you hear? Not only stopping the bubbles in the production process, it breaks surface tension of air bubbles, which a lot of people are not familiar with. So what happens physically with the deformer process? So now it removes trapped hair from solid addition and it prevents pinholes on the wall. I know most of you, you've talked about pinholes, there's a pinholes, you understand? So deformer helps to remove the pinholes on the wall. So if you skip deformer, what happens? One, forming weak frame and surface defeats. So anytime you say, oh, I don't have deformer, oh, so let me just skip deformer and let me just add kerosene, is going to stop the bubbles. You are doing your production process bad because it's you're going to have a surface default later on. You understand? So air is invisible, but it destroy performances. There's so many manufacturers are not aware of. So let's move over to step 9, the thickener. You understand? So what happens chemically when it's been added? It hydrates but remains inactive until pH is raised, which so many people are not aware. You say, I don't want to use ammonia. Oh, the smell is toxic. Let me skip it. Did you hear? When you add your thickener, your nitrosol, your Bamacol, you understand? It hydrates but remains inactive until pH is raised. The pH also has to be controlled. So, what happens physically? One, it begins viscosity building, it controls sagging and settling. You understand? So if you dump your nitrosol, that's after dissolving, what happens? Fishy eyes on the wall, lumps, and unstable viscosity. See, thickener must be respected. If you dump it, it will punish you. Some of us that have been manufacturing, you know what I mean. So let's move on to step 10, the pH adjuster. So now, ammonia should be about 25%, which is the pH 8.5 to 9.0. So what happened chemically when you incorporate your ammonia? One, it activates the activates the thickener, sorry. Also, it stabilizes the acrylic binder. So what happens physically when the ammonia is added? One, viscosity rise smoothly and the product becomes creamy. So if you add your pH wrongfully, what happened? It taint the product, settling and spoilage. So too much of ammonia can actually result to all of these because pH is the switch that turns the system on. So now let's move over to the step 11, which is the binder addition, the backbone of every water-based paint. So now your acrylic should be about 50 to 55% solid. Remember, I explained this earlier on. If you just skip to this level, go back to watch. So what happens chemically when you add your acrylic? Acrylic forms continuous elastic film. It bonds the fillers to the wall. So now, what happens physically when you add your acrylic? One, adhesion, two, waterproofing, three, flexibility. So if added earlier, yes, a lot of people want to add acrylic in the early stage. They think it's a profession process. So what happens when you add your acrylic earlier? you have a poor dispersion, and you have a weak structure, because binder comes after structure, not before structure. So let's move on to step 12, which is the plasticizers and the coalescents, which of course is our texanol. So what happens chemically when texanol is added? One, it assists the flame coalescent, it reduces the brightness on the wall. So have you seen that these chemicals have two to three, and they also have other functions? So now what happens physically when acrylic binder is added? One, it prevents cracking as well. Two, it improves flexibility. And if acrylic is skipped, because some persons will want to skip this product, what will happen? Two, breathed fillers. Three, cracking after drying. This is what allows the flame to heat itself. Not heat, heal. Yeah, this is what allow the flame to heal itself. You understand? So acrylic must be added rightfully. So now let's move over to the step 13, which is the final deformer addition, because we added the deformer into process. I usually like to add my deformer into process, you understand? So at this process, it removes the micro bubbles, and it introduced during binder addition, you understand? And of course the final polishing before packaging. And of course, the step 14, which is the preservative. So what happens chemically when the preservative is being added? It stops micro back growth, it prevents gas formation and other. So if skipped, what happens when you skip preservative? One, you have spoilage. Two, you have swollen buckets, foul odor, smell, and all of that. A product that spoils is already dead. So of course you need to preserve your product. Not only preserve your product, you need to know the right dosage during addition. And of course we have the step 15, which is the final check, and the heart ratio. So at this process you have to adjust your viscosity with small water only, and you have to check your pH, you understand, and you let your product rest for about 10 to 15 minutes. So never pack a stress product. That is why you need to leave your product to rest for about 10 to 15 minutes. And of course, step 16, the packaging and the rest. So you pack your product, and of course, you leave it for 24 hours before dispatch. Resting allows the system to stabilize. You understand? So don't do that mistake after producing. You just go and apply. No, please. If you cannot wait for 24 hours for your product to properly stabilize, you can give it for 2 to 3 hours before usage to avoid all the dots, marks, the pinhole, and all of that. Because if this product don't stabilize very well, you just produce, boom, and you send it out and you start using, the product is going to have some kind of little defaults. You understand? So you probably let it to set and rest for stabilization for about few hours, if possible 24 hours. Every step exists because of chemistry plus physical, not tradition. You understand? So skipping one step does not save money. It creates future failure. And that is why I'm taking my time. So I know this video is quite long, but I'm taking my time to explain the right order for you. You see, professional acrylic crack filler is flexible and waterproofing, and it has a long-lasting, engineered for contractors, and of course wall surface preparation. So you have to get it rightfully. So now let's look at the failure, that is cracking after drying. We need to look at all of these, so you people will be able to get the right order. This is like a masterclass for premium acrylic crack filler. I know why I'm giving this out to you, because I want you to have a proper understanding. So now the product looks perfect when applied. 2 days later, the cracks comes back. The contractors blame the wall, but the wall is innocent. So what really went wrong? You see, crack happens because the filler cannot move with the wall. Wall expands, wall contracts, paint system must move with them. So now, what is the cause? Number one, low acrylic binder. Number two, no reinforcement fiber. Number three, no plasticizers. Textanol. And of course, high filler stress. The product dries rigid, not elastic. So now, how to avoid all this failure process and of course you have to by preventing it, it's simple. One, your acrylic binder should be 50 to 55% solid. This forms elastic flame. Two, your fiberglass, which is the microfiber, absorbs movement. And of course your texanol allows the flame flexibility. Now, you know that you need to sand this filler. Instead of smooth dull, it turns to chalk. That is not sanding. So let's look at the failure of the powdering after sanding. So what really went wrong? You understand? In the powdering process you're seeing. So powdering simply means fillers are not locked together. One, the causes are too much calcium carbonate, too little binder, poor dispersion, and wrong filler balance. The binder cannot hold the particles together. So, how do you prevent the process? Like I said, you have to one, correct the binder to filler ratio. Two, proper dispenser, which is your Calgon PT, and of course, your fine mesh calcium carbonate. You have to know the size that you are using for that particular product. And you know, for the premium acrylic filler, crack filler, we are using 800 to 1000 fine mesh size. So, failure number three, peeling from the wall. Very important. So, what happens when this particular product peels from the wall? It means the filler dries well, but the moment you apply the paint, everything lifts off like skin. What really went wrong? Peeling simply means no penetration into the substrate. So, how to avoid this is one, or no, what are the cause? Number one is low quality binder, binder added too early, poor pH control, dirty or chalky surfaces. And how can you prevent all of these? Your acrylic binder should be added after the structure process. Also, you need to have a correct pH level, and your acrylic should penetrate the plaster and the cement. So let's look at failure number four, settling in the bucket. See, you open the bucket after 1 week, water is on top, heavy paste at the bottom. The production is already dead. What really went wrong? Settling means gravity, default in the system. So, what are the causes? So, the root cause is one, no thickener structure, no radiocology control, wrong mixing order, poor Jeniper plus Nitrosoft system. So now, how do you um prevent this process? One, Jeniper stabilizes flow, Nitrosoft control suspension, and proper pH activate the thickener. So let's move over to failure five, shrinkage after drying. You apply the filler thick, it looks fine, wet. When it dries, the surface shrinks. So what really went wrong? What happened? You see, shrinkage means when water level too fast and there is no internal control. So what are the root causes? One, no talc, no plasticizers, too much water, wrong filler geometric. So how can you prevent all this process? Now, talc helps reduce shrinkage stress. So failure Number six, low coverage and poor body. You keep applying, it still looks thin. That is not coverage, that is waste. So, what really went wrong? Coverage depends on the particle packaging and the light scatter surfaces. You understand? And it's not only talking about calcium carbonate, titanium dioxide. You understand? So, now what is the root causes? Corrosive calcium carbonate, no titanium in your production, and of course poor dispersion, which is the mixing, the addition of the carbon pt to grind all these chemicals, especially your fillers. So how can you prevent all this process? Number one, your calcium merge, which is the size. You have to make sure you know the particular fine mesh size you're adding. Two, you just incorporate small titanium dioxide addition. But if it's for other paints, other water-based paint, then you use the right titanium dioxide measurement. So failure number seven, water damage and re-emulsification. So you, as in rain touches the wall, the filler soften again. That product was never waterproof. So what really went wrong? See, water resistance comes from flame continually, not thickness. So what is the root cause? Number one, low acrylic solid. Two, no coalescent. You see, most failure don't happen on the wall. They happen in the mixing tank, and every failure has a reason. Manufacturing is not guessing, it is understanding. You need to understand the order, the process, the system. That is manufacturing. So now let's look at costing, position, and premium branding. You see, premium is not price. Premium is performances, consistency. Contractors don't want cheap. They want predictable results. And this is what makes you product be premium, and your branding has a positional cost that will not devalue you, rather position you out there as a premium paint brand. Before we close, please remember to subscribe. Don't just watch. Your support keep this channel growing. To our Glenify students worldwide, channel members, and of course our subscribers, thank you. And if you are new here, you are welcome. We appreciate you. Please give this video a thumbs up by liking this video. It helps a lot. Quick question and answer honestly. Okay, have you ever produced a crack filler that cracked again after drying? Type yes or no in the comment. Now, let me say this clearly. I want to know I'm not talking to myself. If you want the complete chemical measurement for producing 20 liters of prime acrylic crack filler, comment premium acrylic crack filler in the comment section. I will personally reply you with the full measurement list. That is to say, you've watched this video to this very point and you need the right measurement to produce your own product, because I know that you would have followed the order and the system that I taught you in today's tutorials. Also, if you want to learn paint manufacturing professionally, whether you're a beginner or already producing paint, join the Zero to Manufacturing. The link is in description. That is where I teach the full system, not guessing, not shortcut, but real factory logic. You can also check out our Glenify Paint ebooks for advanced expert formulation. Thank you for watching until the next class. Bye for now.